Okay, the next topic is non-specific resistance. Okay, non-specific obviously is talking about the defenses that we have that they are not necessarily specific for one particular type of pathogen. Okay, so the first one, at least in this book, is divided in first line of defense. In this case, this consists of the external barriers that we have, such as the skin and the mucus barriers, and they work in a way to stop the microorganisms from crossing them. Therefore, they don't allow the microorganisms to have access to the internal part of our body. So they are, kept outside because of the different type of substance that we have, such as, for example, keratin on top of our skin, or in the mucous membranes, we have, for example, lysosome that is going to destroy bacteria. Lysosome is also part of the tears as well as saliva in the case of the eyes and the mouth. So the next one that we have is the second line of defense. In this case, this one is also non-specific. Okay, and this is going to consist on the cells such as leukocytes and macrophages, as well as some proteins found in the blood, natural killer cells, inflammation, as well as fever. The next one, or third line of defense, at least in this book, is going to be the one that is going to be specific. It's called specific because it's specific for certain type of microorganisms. For example, the antibodies that help you against chickenpox, they are not going to defend you against the flu, because the antibodies against chickenpox are specific for chickenpox and not for the flu. You will need to create antibodies against the flu in order to be able to defend you against that particular type of disease. So if we keep scrolling down, we're going to see some details about it. So for example, we have in here external barriers. If we keep scrolling down, we can see external barriers. As I was saying, external barriers are going to be basically the skin as well as the mucous membranes that we have in our body. In the skin, we have the cells that contain keratin, which are going to be the keratinocytes. The keratin is a very hard protein that will protect our skin and is going to make very hard for the microorganisms to cross it. Not only that, but we're constantly shedding these cells, so it doesn't allow a lot of time for the microorganisms to develop and multiply and penetrate our skin. So it works as a barrier, very important to protecting our body. Mucous membranes, obviously, they're going to produce mucus, which is going to trap the microorganisms in there, not allowing them to cross and invading our body. As I mentioned before, also we have this enzyme called lysozyme, which is going to be an enzyme that destroys microorganisms. It's also, you have it here, lysozyme, that is also present in tears and saliva, as I mentioned before. Underneath the epithelial and the mucous membranes, we're going to have part of the connective tissue. We're going to have in there the glycosaminoglycans, which is going to be part of the ground substance. A very important glycosaminoglycan is hyaluronic acid, which is going to give a viscous consistency to the connective tissue, not allowing these microorganisms again to cross it. So there's a lot of proteins that you're going to have at the level of the surface of our body that are going to help us in protect our body against microorganisms. The next one that is also non-specific is the leukocytes as well as macrophages, in other words, cells. We have in here the leukocytes, which are going to be the white blood cells. We have some of them right here. Neutrophils, obviously, those are going to be the main cells that are going to be in charge of destroying microorganisms based on phagocytosis. That's one way in which they destroy the microorganisms. But another one, even more important than that, is that neutrophils are going to use chemicals located in the different tissues that we have, and they're going to transform this into superoxide, hydrogen peroxide, as well as hypochlorite. Hypochlorite is a very important component, for example, of Clorox. Let me see if it's in here. Yeah, right here you have superoxide anions and hydrogen peroxide as well as hypochlorite. These are very important chemicals that are going to cause destruction of most of the microorganisms that are going to be available in that specific area. And not only, unfortunately, these are very potent chemicals that not only are going to destroy the microorganisms, but also the neutrophils are going to be destroyed as well. So yes, neutrophils help us destroy a lot of microorganisms, but they are going to be killed in the process. Next ones that we have are going to be eosinophils. Eosinophils are also white blood cells that they're going to be specific a lot of times just for parasites as well as allergens. These eosinophils, for example, are very important in the people that have asthma. So they are going to also produce superoxide as well as hydrogen peroxide in order to destroy the parasites in particular. They're going to secrete some enzymes in order to limit the action of other chemicals that, for example, the neutrophils are going to produce, as well as the basophils. Okay, right here we have basophils. Basophils are going to be cells that you find in the blood. Similar to this are going to be the mast cells. The only difference is the mast cells are located in the tissues. Basophils and mast cells have the same functions, which is the secretion of chemicals with the purposes of allowing more cells to go into the areas of infection. So therefore, they're going to secrete quite a few chemicals in order to allow us to more white blood cells to reach the areas of infection. Some of the chemicals that they're going to produce, the basophils as well as the mast cells, are going to be histamine. Histamine is a very potent vasodilator that will allow the increased blood flow into the areas of infection, so more white blood cells can go in there. Also heparin, that is going to avoid blood clotting. Since you don't form blood clots, then there's no stoppage in the flowing of blood, and therefore there's no stoppage of the white blood cells reaching the area of of infection. You're also going to have, for example, prostaglandins that are going to increase temperature, and they're going to produce pain as well. So very important in the function in the infection is basophils, because that attracts basically more white blood cells. The next one that we have is going to be lymphocytes. Lymphocytes, we have two main kinds, lymphocytes T and lymphocytes T. There's a very important type of cell, which is the natural killer. Natural killers are the ones that are going to be very important in the non-specific area of the immune system. Lymphocytes T and lymphocytes B are also part of the immune system, but they are going to be very specific or related mostly to the specific defense of our body. So the reason why we have in this area, which is non-specific, is because the natural killers are going to be working in this area. Natural killers are in charge of destroying cells that might be infected with viruses, cancer cells, transplant cells, okay, and as well as other microorganisms. The next type of cell that we have right here is monocytes. Monocytes are also very important in the destruction of microorganisms. So monocytes are the ones that you're going to find in the blood, but when they come out of the blood, they're going to turn into macrophages. They go to the area of infection, and in the area of infection, they are going to destroy and phagocytize many things with the purposes of cleaning, if we can put it like that. They're going to destroy microorganisms, but also they are going to phagocytize dead neutrophils, debris that may be in the area of infection, some cells that may be dying, they are just going to destroy them. And obviously, this is going to be done through a process of phagocytosis. So one very important concept to understand regarding macrophages, they are also phagocytized, but they are to it basically with the purposes of cleaning and removing and leaving the area prepared basically for repair. So if we keep scrolling down, earlier we talked about the different type of cells and substances that we have on top of our body, like in the skin as well as mucous areas, and the function of some of the proteins that we have in there in order to avoid microorganisms from going inside your body. But in addition to those proteins in the surface areas, we're going to have proteins that are going to be located in our blood and inside our body, basically. And these proteins are going to be interferons. Interferons are proteins inside our body that are going to be produced by the cells when they are especially infected with viruses. They produce these interferons, and these interferons are displayed in the cell membrane. And this basically has two purposes. One of them is to flag the cell as being infected so it can be destroyed by a natural killer, for example. And another one is to inform or to let the other cells that there's a viral infection and that this cell is infected, so the other cells can initiate, defense processes in order to stop the invasion of the virus. So interferon is a very important protein, again, basically to allow the cells to be destroyed when they are infected with viruses. The next set of proteins, they are going to be part of the complement system. It's called complement system because they complete the function of the antibodies. Again, the antibodies is going to be part of the specific resistance. So the complement system has a part that is non-specific, but has a part that is specific. So we're going to talk about this in this case. Again, the complement system is a set of proteins that they're going to work with the purposes of destroying microorganisms. The way they are activated, there are three main ways. One of them is a classical pathway, the other one is alternative pathway, and the other one is the lectin pathway. Classical pathway requires an antibody. So this one right here is the one that is part of the specific immunity. Okay. However, these other two are not. These are part of the non-specific immunity. Alternative pathway, basically the protein C3 is going to be, cleavage is going to be broken into other proteins, and that's going to initiate the whole process. In the classical pathway, once the antibody attaches to the antigen, that initiates the whole process. And then the next one is lectin. Lectin is a protein that is going to attach to carbohydrates that the microorganisms have in the cell membrane. And once they attach to the carbohydrates that they have in the cell membrane, then is going to initiate the pathway. So these three different type of mechanisms, this mechanism with these three different ways to activate it, basically are going to have the same result. The C protein is going to be transformed into C3A and C3B by these three ways. And the result of that is going to be these four items that you have right here. The first one is inflammation, immune clearance, phagocytosis, and cytolysis. Inflammation produces the four cardinal signs of inflammation, which is red, heat, pain, and swelling. Immune clearance is when the antibodies and the antigens get together. They are going to go with the red blood cells into the spleen and the liver, and the macrophages in the spleen and the liver are going to destroy this antigen-antibody complex. The next one is going to be the C3 is going to attach to the bacteria, and this is going to flag this bacteria in order to be destroyed by the white blood cells in our body. This flagging by the C3 is called opsonization, and that's going to obviously initiate phagocytosis. The next one is the lectin attaches to the carbohydrates, right? And then obviously that's going to initiate cytolysis. In the case of cytolysis, the C3B is going to activate C5, C5 activates C6, C7, C8, and C9, and that's going to create a hole in the bacteria, and this hole in the bacteria will initiate the destruction of the cell by cytolysis. So again, the four steps are going to be inflammation, immune clearance, phagocytosis, and cytolysis. We keep scrolling down, we can see in there the complement activation. We said classical pathway, alternative pathway, and the next one is obviously the lectin pathway, as you can see in there. The results of the complement, as we said, there are four of them. They're going to be inflammation, immune clearance, phagocytosis, as well as cytolysis. We already mentioned that as well, and I explained how this is going to happen. Next ones are going to be natural killer cells, which I already mentioned as well. I said that that's a type of lymphocyte, and the main job of it is as part of the non-specific resistance, where it's going to destroy cells that are infected with viruses, cells that are going to be cancer cells, cells that are going to be transplant cells, as well as some other microorganisms. Okay, so then we get scrolling down, and then we're going to go to the other topic.